My name's Dylan. I own a shop called Inertia Race, and for the most part I do custom fabrication and some product development here and there. I also do data collection for other engineering companies in Australia. That varies wildly from nuclear stuff to like rubber products. Yeah, it's pretty wide. It's hard to narrow down just to one thing. In my own business, I mostly use the 3D scanning to kind of collect general data, whether it be flanges or I might want to design a part that fits to a space. I'll create a scan assembly even, and then work from there mostly on the computer and make my prototypes. So if the car's here, I'll collect the data, work on the product, and the next time I get one along, or speak with people to test if the products I've made. The other side of it is the engineering companies. So that's just really basic 3D scanning stuff. It's a wide range of things. It might be big drums, like those weird kegs, or it might be small intricate parts. I mostly stick to using the EinScan HX because it's very versatile. I can deal with black surfaces and the shiny stuff really well. But for the higher detail stuff, I'll switch to the tripod and the Pro HD powder markers, that kind of approach. It's a slow approach, but it just gets detail on a different level that you can't really get with the handheld scanner. This one is getting the engine in the back with a Porsche transmission and all that stuff. So generally I'll try and do a scan of kind of everything together, and I'll start disassembling the car into smaller pieces and then do scans of those individual objects. And then using just the Geomagic Essentials, I can pretty much align my master scan and start piecing up all those other collections of data into Geomagic and save them as individual files. Then once I get to SolidWorks, I can upload those as individual parts into an assembly and turn them off and on. So I can turn off, say, a subframe or control arms or suspension components. I can really break the car down and work in the spot I need to work on. I'll dumb those individual scans. I will decimate them as much as I feel I can get away with, but anything that I feel is important, because I've broken it down to the small sections, anything that is important, I can leave that high detail. And so for instance, like the outside of the car, I don't need 0.01 accuracy. I can go a millimeter or whatever accuracy and decimate it and cut down the data a lot. I'll decimate to a tolerance, but yes, anything that can be a looser tolerance, I'll definitely get rid of as much data as I can. Because once you've got 100 million triangles in one file, it's gonna bog down. It's gonna be hard on the computer. I'm pretty on top of how I'm scanning something. If I'm scanning a car, I'm not just gonna start at one corner, walk around and create a 10-meter distance from the origin. I'll probably start from the center of the roof, work to a corner, go back there, work to the corner, and really shorten how far away I am getting from that, like the origin of where I started. It's the way you scan something, the bigger the object gets, the truer that gets. The smaller the object gets, the error, you can't even tell it's there. By the time you get down to something, say like a gearbox, it's fairly easy and straightforward to get the data from. People have issues when it's, say, something like a subframe where it's maybe not that big, but it's a bunch of, say, tubular sections together. So they have to, again, travel a long distance to get around it from one point to the next, just say. It gets very difficult from there. You might marker up the floor, sit it over the top and beeline it, or come up with alternate strategies to do it. Might put, introduce things in the gaps to allow you to get from one place to the other. In the same way, if you're scanning something thin, you might stand it vertically, scan one side, go to the floor, get up onto the other side, and do something like that.